So what we do is we take a DC generator and we attach it to a motor. And the output of the DC generator is proportional to the speed of the motor. So what I have here is I have a unit. And what's nice about a DC motor is that a DC motor can also be ran as a generator. So what I have is I have a little MG set that I built here. It's just one of them I'm going to run as a generator. One of them I'm going to run as a motor. Let me pick up the motor again. And so what I've got is I've got my meter hooked up on the output of my generator. Can y'all see? Okay, do I have enough room to get everything together? So this guy is my tach generator, and this is my motor. And we call these MG sets, but what we would do is we would use the output of our generator to calculate speed. Calculate the speed of the motor. Because if you notice, when I turn my speed down, what do you notice about, what do you notice about the output of the generator? Is it going down or going up? Okay, if I speed my motor up, what is the output voltage? Goes up. And this is linear, guys. The output voltage would be directly proportional to the speed. So right now, if I measure 10.72 volts, if I knew what speed was represented by 10.72 volts, then I can interpret the voltage as the speed, right? Y'all understand that? That makes sense. So this is a 15-volt motor. So this guy puts out about 12 volts. This is not the voltage feeding the motor. This is the voltage off the tach generator. Y'all understand that? So this guy puts out about 12 volts when the motor's running at a certain speed. The problem is I don't what? I don't know the speed. So you'd have to know what speed this actually means. You got it running at about 15 volts. I don't know. I don't have a meter on it. I'm just putting it on 15 volts on my power supply over here. So exactly what it is, I don't know. But that would be critical too. We would have to know exactly what speed it runs at a precise voltage, right? You understand? So what I would have to know normally what we do is we run the motor at its rated speed, its rated voltage. And that would give us its maximum speed. Understand? And then we could use, once we know the maximum speed, then we could calculate the number of volts per RPM. That makes sense? Yes or no? So let's say a motor runs 2400 RPM at 15 volts and it generates 10 volts. So that's what I'm interested in. I'm not interested on the voltage that's running the motor. I'm trying to get what? The voltage I get out when the motor's running at a certain speed. So let's say my motor gives me 10 volts when it's running at 2400 RPM. Equals 10 volts out of my generator. Okay, so that means if I got 5 volts out, what would be the speed of the motor? 1200 RPM. That's exactly right. What would I get out if it's running 5 RPM? Well, now I've got a little problem, right? You understand? So what we would do is we would take, right? So what we would do is, this is what we're getting out, this is what we're getting in. So what I'd do is I'd take my 10 volts, and then I would divide that by the speed. And this would give me volts per RPM, right? So somebody get their calculator out and see what this comes up. So this is what you'd have to do. This is what you would have to know on your tach generator. You'd need to know what voltage you get out for a certain RPM, right? You understand? What's that? We need to not round it. Is it exactly 4 minutes? 4.16. Yeah, you need to take this out because this is going to be how accurate you are, right? 2 usually go 3 or 4, so because it's how accurate you are, right? You understand, and what you would do inside your PLC is that this is what you would use. You would do this math that we're doing right now. So what I would do now is I'd say, and this is milli, right? No unit, right? Okay, so if we carried it out that far, that might be good. And this is milli, right? You understand? So now I'd say, okay, let's say I'm getting 8 volts out. Well, I could take 8 now, and I could multiply it by this 1.167 milli, and that would give me my speed. Oh, I'm sorry, not multiply, divide. 8 divided by 4.167 milli, if we transform, and what would that give? What's that? 8 divided by 4. If we did this right, let me go back. So I'd take 10, which is the output of my generator, and I divide that by 2400, which would give me that number right there. Okay. So what I'm going to do now is I'm just going to store this in my memory. And then I can say 8 divided by recall. And that means my generator, that the motor will be running at 1,920 RPM. Okay. So I said, okay, this gives me what each volt is worth right here. So what I did was I got my transfer function, which is that number right there, right? You understand? And now what I can do, once I got that, is I can come over and take the voltage I get out of my motor. So I said I'm going to get 8 volts out of the motor. And then I come up here and I divide it by that transfer function. And then that gives me the speed. So all I would have to do is if I had an A to D converter coming into my PLC, is I'd figure out what binary number represented that, and then I could go directly to speed by doing a little math. So what would we get out at 5 volts? Well, I'd say 5, and then I would divide it by my, what we call our transfer function, and it says I should be running at exactly 1200 RPM, right? If I get 10 out, then I could come up here and come up with this little math thing that I came up with, and it says I would be running that, and I did it wrong. I'd be running at 24 hard enough. So now what I can do is I can take any voltage that I get out of my tach generator, and I can do what? I can calculate the speed. And PLCs love to do math. So now I can come from an analog input, right, and do what? And then convert that to a speed. Now, how do I know the speed of the motor? Right. It's a DC motor would say 2400 volts, and it would say this would be the speed, and that would be exactly what you would use. AC motor would give you but it's going to be under a certain load. So what you have to do, guys, is if it's a 5 horsepower motor, you got to put it under a 5 horsepower load, right? You understand? Then put that voltage on there, then measure the output. So motors, when they give you their speed is at its what? Is at its rated horsepower. So if I've got a speed control circuit on there, then that's something we've got to know. So we have to have the ability to measure the speed. So we have these rotary tachs. They have They have a thing that comes out, and then they have a big old angle thing over here, and then you go over there and you put it on the shaft of the motor and let the motor spin. You measure that, right? You understand. We have optical tags, which flash a light, and it flashes the light. And what's nice about these is just most of your motors have a flat spot on the rod, right? You understand? So we can put a set screw into it. And what we would do is we just flash that light until what? What you do is you got yeah, y'all might have to come up here and see this because I faked one of these out. So y'all come up here for a second.